Hello, Legacy Sabers, Marsh here. So today we're going to start sequences and series. Most focus that we're going to focus on today is sequences. You're going to want your foldable so that you guys can follow along. So, first of all, what in fact is a sequence? Well, a sequence is just a list of numbers or objects that results from an equation. Like 1, 2, 3, 4, 5 would be a sequence because I'm adding 1 each time. It's that kind of idea. You guys have played with sequences probably for years in your math classes. Now we're just kind of getting formal definitions. A term. A term is just each number in a sequence. So 1, 2, 3, those are all terms in that sequence. A rule is probably the word you've heard. It's an equation that generates the terms. So, like, what's the rule that I did? Well, I took whatever number and I added 1 to it. That kind of information would be a rule. Now, first thing that we want to figure out is how do you find terms of a sequence? So I'm given a rule of a sub n equals 2n plus 5, and they want me to find the first 6 terms. Yes, guys, this is as easy as you think it is. So I'm plugging a 1, 2, 3, 4, 5, and 6 into this formula, and I'm going to get some numbers. So 2 times 1, 2 plus 5 is 7. 4, 9, 6, 11, 13, 15, and 17. It's going up by 2 each time, right? Okay, so that one, you're like, really? That's all? That's not all we're doing today, so don't get comfortable yet. Let's try another one though. I'm going to write the first 6 terms of the sequence represented by f sub n equals negative 3 n minus 1. So I'm going to plug in some numbers for n. Again, first 6 terms is 1, 2, 3, 4, 5, 6 is n. So negative 3 to the 0 power is 1, because anything to the 0 power is 1, right? 2 minus 1 is 1. Negative 3 to the first is negative 3. 3 minus 1 is 2. Negative 3 squared is 9. 4 minus 1 is 3. 3 to the negative 3 is negative 27. 3 to the negative 3 to the fourth is 81. And then 243 with a negative attached would be the first 6 terms of that sequence. Now, what if I'm given the terms and I need to write the rule? Oh, I know, this might be a little bit more difficult. Here's how I like to accomplish this task. So I'm given the terms 1, 6, 11, and 16. They want me to write the rule for the nth term. So I'm going to actually see it as a pattern. So this is me plugging in the first 4. 1, 2, 3, 4, and I generated a 1, a 6, 11, and a 16. So now here's what I want to do. I want to know if I plug in a 1, I need to get a 1. If I plug in a 2, I get 6. That's kind of different. So maybe I'm multiplying by 3 somehow, right? Because that could get me a 6. But 3 times 3 is 9. That wouldn't work. If I plug in 1, I need to get a 1. Well, I did notice something. I'm noticing that I'm adding 5 each time, right? So kind of like when this one added 2 each time. Do you see how the 2 was a slope? Well, maybe my 5's my slope. So a sub n equals 5 n. Now here's the thing. How can I get this to work out? Hmm, hmm, hmm. Well, 5 times 2 is 10, and I need to get 6. So what if I took away 4? Will that do it? So 5 times 1 is 5 minus 4. Well, that's 1. 3 times 5, 15. Yes, I got my formula. So a sub n equals 5 times n minus 4. So I literally am just plugging in things, guys. I'm trying to figure out how can this math happen? Then using the rule, I'm going to find the 102nd term. Holy buckets, 102nd. We're just going to plug in 102. So they want to know what is the 102nd term. So I'm going to go 5 times 102 minus 4. 5 times 102 is a really big number. That would be 510 question mark. Marsh needs her calculator. Yes, and then subtract 4, 506. So A sub 102 is 506. Yay, us. Found it. Let's try another one. So I got 3, 8, 15, and 24. They want me again to find the rule. So again, I'm going to kind of make my table here. There we go. We're not going up by a constant amount this time. Well, that kind of stinks. How could we get 3? How could 2 become 8? Are we going up by a constant? Are we multiplying by something? 8/3 maybe each time? What's 8? 8/3. Well, that's not it. Well, it's definitely not a linear function, right? So, and it's not exponential, because that would mean it's going up by a constant amount of multiplying. So it's got to be something different. Maybe squareds. Let's try that. So if I square my term, well, 1 squared is 1, but I would have to add 2, right? 2 squared is 4. I would have to... Oh, that wouldn't work. Well, it's got to be something maybe with a squared. How would I get 3? I would have to multiply. Oh, what if I did that? What if I did n squared plus 2n? Would that do it? So I would get 1 squared. That would be 1 plus 2. Yeah, that'd be 3. 2 squared, 4. Plus 4 is 8. Ooh, we're doing something here. 3 squared is 9. Plus 6. Oh, ho, ho. Found it. Let's find the 10th term in the sequence now. So a sub 10. So that's 10 squared plus 2 times 10. 100 plus 20. That is 120 for the 10th term in my sequence. Let's try another one. I know these are kind of strange. They're kind of difficult, but we got this. Again, I'm going to make my table here. Kind of sometimes helps me see what's going on. Okay. Well, not a constant. I'm not adding a constant. Oh, or am I? I'm adding 4 each time. Ooh, interesting. But I'm swapping signs too. Well, if I'm swapping signs, that'd probably be like a -1 to the n, kind of like how this guy did it. Kind of that negative was in there. So what if I'd had -1 to the n? So then that would give me a negative, a positive, a negative. And then, well, we're constant going up by 4. So we'll go times 4n. So I plug in 1, we get a -4. If I plug in a 2, well, we would get +8. That's right. This has got to be my formula here because it is a linear graph, right? It's going up by a constant amount without that negative. You know, the negative's kind of funny. But let's go ahead. So I'm going to go a sub n. I'm going to make sure I note that. 10th term. So I'm going to plug in 10 again. Well, this is a positive, right? Because it's even. So I'm going to get 40 for an answer for this one. Let's try the last example. All right. So, oh, I got fractions. Gross. Okay, but that's okay. 1/10. 2 is 3/20ths. Okay. 5 is 5. Oh, no, excuse me. 3 is 30ths and 4 is 7/40ths. Well, I can definitely say without a doubt that the denominator is 10n, right? Now, how are we getting a 1 up there? Well, we're going up by a constant amount, right? We're going up by 2. So it's probably 2n up there because we're multiplying by 2 each or adding 2 each time. So that's my slope of my graph or slope of my rule. But I had to get 1. So 2 times 1 is 2. I would have to subtract 1. Would that work? 3 or 2 times 2 is 4. Minus 1 is 3. That looks right. 6. Yas. Got the formula. It works for all of the terms that they gave me. Now let's find the 7th term. All right. 14 minus 1 is 13. 70ths. And that is the answer. And that is the end of this video. I know sequences are a little bit difficult to find the pattern, but sometimes it's just being creative with your math and thinking through what kind of things could it be and what can't it be. And a lot of times when I'm looking at them is I'm trying to see, is it a constant amount that I'm multiplying by, or is it a constant amount that I'm adding by? That's sometimes, if those two things I can answer those answers, usually that means I can figure it out further. But until I see you next, I will see you later, Sabers.